Okay, guys, so this is literally my 5th time trying to record this lecture, and I am so frustrated right now. You have no idea. Anyways, we're gonna get started. I'm hoping to do this really quickly. So intro to Doodle Sheets, okay? Hope I talked all about it on my last video that hopefully you just watched because it should have led you to here. Okay, so once again, the Doodle Sheet slideshows correspond to the notes. Okay, so right here, this says box A, what is a hypothesis? If you look here, it's Doodle Sheet box A, what is a hypothesis? Okay, so I'm going to start on slide 1, because why not? So just remember for this part, you are allowed to work with a partner because it's the what you think portion. So find a partner. Remember, you do need to social distance, so sit 6 feet apart. Please listen to the sub, okay? So anyways, day 1, intro to Doodle Sheets. What are they and how do we complete them? We went already over this in the last video. These are your guided notes for this class, and you complete them by going along with the corresponding slideshow. This will either be done live in class or over Screencastify. Unfortunately, with the 40-minute class time, this might be something we do more at home, so that way we can try and do the activities that you need to interact with people in class. But it will depend on the unit and what's going on and what needs to be discussed. Okay, so Doodle Sheet box A. So hopefully you're with a partner. The question is, what is a hypothesis? You're going to read the choices in box A and highlight any that you think pertain to hypothesis. It's okay to have multiple answers. So what I want you to do here is pause the video and go ahead and do this. Okay, I'm not going to wait. I expect you to pause the video, take a second and do this. Okay, box C. We are going out of order because these are the things you need to be discussing with your neighbor. Okay, so what is a scientific theory? Talk to your partner. What do you think a scientific theory is? Type up your notes. Okay, make sure you pause the screen because I'm going to keep going. Okay, so box D. What does it mean to do science? So you're going to fill out the what my group thinks portion. Okay, my group thinks. Okay. Box E, you're going to describe a scientific model. Take a moment, pause the video, discuss it with your partner, and then write something down. Okay, so box F, what are observations? What do you think they are? What your partner thinks they are? Take a second, pause the video, discuss it with your neighbor, and write something down. And finally, box G, what is the scientific method and how is it used? So take a second, talk to your neighbor, go over what you think it is, and then next we are going to go over what it actually is. Okay, so now we are going to do your independent work. So you can actually, depending on if you had time to finish this in class, you can still work with your partner if you want to go through this video together, or this might be homework depending on how you used your time. Okay, but we're going to go ahead and keep going. This is what scientists think. So on the Doodle Sheet, this is, we're going to do box B, and then the right column is everything we're going to fill out right now. So remember, on this Doodle Sheet, I grade for completion. So all of these boxes need to be answered if you want points. Okay. So box A. Okay. So what is a hypothesis? The correct answer is a tentative explanation, a statement that can be tested, and a statement that may lead to a prediction. Also, I combined the two. A statement that may lead to a prediction and may guide an investigation. A hypothesis is not a prediction nor an educated guess, and not all investigations begin with a hypothesis. Okay, box B, an hypothesis is, so this is like the full written out definition. We're going to combine all of those and make it a definition. So hypothesis is a tentative explanation that can be tested and may lead to a prediction and guide an investigation. So remember, not all investigations start with a hypothesis. Okay, I know previously when you learned about the scientific method, the first thing you did was come up with a hypothesis. However, this isn't always the case. In real science, an hypothesis can help, but it's not 100% necessary. Box C, what scientists think of scientific theories. So you're going to put down these 4 bullets on box C on the right-hand side, okay? Scientific theories are inferred explanations strongly supported by evidence. So just because something isn't a scientific theory, it's not like when you go, oh, I have a theory, or you have an idea. So for something to be considered a scientific theory, it basically means that all scientific evidence up until this point points to this to be true. It is referred to as a theory because at the end of the day, there is no Earth handbook that gives us the answers. For all we know, in 100 years and 50 years, heck, maybe even next week, there may be some information that pops up that can completely change our concept on one of these theories, these scientific theories, okay? So a scientific theory is something that, to this point, all academic evidence refers to this to be true, okay? These have been tested many times by many scientists over however many years, okay? It's not just one scientist who did an experiment and now it's scientific theory, okay? So once again, inferred explanations that are strongly supported by evidence. They have been tested many times and are used to make predictions based on observations. So you should have 1, 2, 3, 4 points noted in box C on the right-hand column under the what scientists think. Okay, box D, what scientists think of doing science. So remember, if I'm going too fast, you can always press pause to make sure you're getting these notes down. So doing science, is observing a phenomenon and asking questions about it, okay? And it's also going to lead to developing models to explain. So you have 2 bullet points that you need to get down on box D on the right-hand box. Is there only one way to do science? So this doesn't have a number on it, okay? This doesn't have a letter of the alphabet. So this doesn't have to get written down on the doodle sheet, but it is information that is useful to know. So is there only one way to do science? So absolutely not. There is 100% not one way to do science. So science is about answering questions, okay? Someone who is asking a question about astrophysics might approach it very differently than a scientist who is asking a question about ocean life, okay? So science is about answering questions, and scientists will use different methods to answer different questions. I know we're not just referring to biology in this instance, we're referring to science as a whole. And there are so many different subcategories of science that there is no way that there can be only one way to do something. Okay, so box E, what scientists think of scientific models. So you're going to have 3 bullet points to write down. So scientific models are a set of ideas to help explain a phenomenon. Okay, scientific models are simple, based on meaningful data and patterns. They're used to make predictions and are plausible or realistic. Okay, so for example, if you're making a model of, I don't know what you guys, but I did this in middle school. We did a physics project where we had to make a roller coaster for a marble to go over a loop. Okay, so to make that model, you had to make it be realistic. What did you need to do to elevate the tube so that way the marble would get enough speed to go over the loop? You couldn't, for example, have a slingshot or rubber band. Okay, you had to do it in a realistic way, the way, for example, a roller coaster might work. So how a roller coaster works is they get dragged up and then they get dropped at the top, and gravity takes the roller coaster through most of the ride. Okay. So a model should not be judged or right on wrong, but how well it fits the criteria. How similar is that model to the phenomenon that you're trying to explain. And by adjusting the model and making the model as accurate as possible, you're learning more about that phenomenon. Okay, so remember, phenomenon is something that we can see or explore or observe and ask questions about. It's not a specific type of thing. Okay, remember, if I'm talking too fast, go ahead and pause me so you can get this stuff down. Okay, there are many different types of models. So right here, we have a digital rendering of a hurricane. Okay, so this is showing air patterns, and this is showing the clouds and how the air is flowing. This is hot air rising. Okay, so this helps show how a storm is running and what type of damage it might do. Okay, this is a cell model. Okay, very, very simple. Helps us understand what the inside of a cell looks. Okay, this is a model on meiosis, and this is a physical model on DNA and how it's structured. Okay, so when you're building that model, whoever built it, after they built it, they probably had a better understanding of how DNA functioned than they did before. Okay, box F, observations. So what scientists think of observations, so box F, on the right-hand side, you only have 1 point, which is that observations are basically data collection. So when I tell you to observe something, you're essentially taking some form of data, whether you're writing it down or not. Oh, you don't need to worry about it. You're not advanced bio. Okay, so what scientists think? Box G, the scientific method. So the scientific method is a flexible process used for explaining a phenomenon. Okay, it is just one tool, but it's not the only tool. Okay, yes, there are some that strictly adhere to this, but this isn't the only way to do stuff. Okay, remember, if I'm going too fast, please feel free to press pause and play when you're ready to continue. Oh, actually, that's it. Okay, so nice job today, guys. Hopefully you guys got everything down. I am so sorry I wasn't in class today, but I hope this screencast makes it easy. But I hope you guys have a lovely Tuesday.